So we found all the root ports. Now we have to look at the designated ports. Identify them. Well, always remember that when it comes to designated ports, the root bridge always has designated ports. So we label that. Every single segment needs a designated port. So if there's already a root port on a segment, the other port automatically has to be the designated port. So that link, we know our designated port. But now we have 3 links. 3 links, which are not defined at all. So we're going to have to figure those out. Let's start off with the middle link between ASW1 and DSW2. Cost of 4. Is it shorter? If we're standing in the middle of this link, is it shorter to go this way, which is 4 plus 4 plus 4, that's 12? Or is it better to go 4 plus 4, which is 8? 8 is lower than 12, which means that this is the designated port. That one was relatively simple. Now let's analyze these 2 links here. We'll start off with the one on the left-hand side. If we go this way, it's 4 plus 4. It's 8. 4 plus 4, that's 8. We have a tie. So what must be done now? We must look at the bridge ID, the upstream bridge ID. So you're in the middle of the link. Does DSW1 or DSW2 have the lower bridge ID? Well, let's examine that. We're on DSW2 right now, and here's DSW2's MAC address. Here's DSW1's MAC address that we copied earlier from DSW1. And remember, DSW1 has the lower MAC address based on A versus B. So DSW1 has the lower upstream bridge ID, making it the preferred path to get back to the root bridge, which makes this the designated port, which would also make, for this link, this one the designated port as well, based on the same criteria. So have we figured out all the designated ports? Well, 1 designated port per segment. I see 1, 2, 3, 4, 5, 6 designated ports. Or 6 links, pardon me. Therefore, 6 designated ports. We have found all 6 of them. That means that every other port left over is in the blocking state. So this is what we've identified. So let's go one by one and see if this is correct. So for ASW2, for VLAN 10, it is currently the root bridge, and all its ports are going to be designated ports. Let's go to ASW2, type in show spanning tree for VLAN 10. Notice from the output, this is the root bridge. And we can even confirm, based on the root ID, the priority and MAC address match the local bridge ID information. It's the exact same. So we were correct. ASW2 is the root bridge. And notice that the gigabit Ethernet ports are both designated ports in the forwarding state. And they do have a cost of 4, as we were using to figure out the spanning tree topology. Also notice that Fast Ethernet 0/3 is part of VLAN 10 because PC3 is connected to Fast Ethernet 0/3. The access port is part of VLAN 10. Therefore, it's also a designated port. Because traffic's going to flow out that interface down to the end station. So we are correct we are correct in what we identified for ASW2. Root bridge and the 2 gigabit ports were designated ports. Let's go over to ASW1 now and see if we were correct there. So it's a non-root bridge. Gigabit 0/1 should be a root port for VLAN 10, and gigabit 0/2 right here should be blocked. Should be an alternate port, blocking state, not forwarding traffic. Let's take a look at that. On ASW1, we'll use the command show spanning tree for VLAN 10, and the output indicates that we are definitely not the root bridge, and we already identified that before. But look at that, gigabit 0/1 is the root port. We were correct there, and gigabit 0/2 is an alternate port in the blocking state, and the cost is 4 as well. Fast Ethernet 0/1 and Fast Ethernet 0/2, if we see here, they're part of VLAN 10. As a result, they will be in the forwarding state because they go down to end stations. They're access ports, and therefore they're going to be in the designated. They're going to be designated ports as well, so traffic can be sent and received at that particular interface down to the end stations. Let's look at DSW1. We should have gigabit 101 as a designated port, gig 102 as a root port, gig 105 and 106 as designated ports. Let's check it out. DSW1, show spanning tree for VLAN 10. Gigabit 101 is designated, gig 102 is the root port, exactly as we said. And then gig 105 and 106 are designated ports as well. So we were correct there. So far, so good. And lastly, DSW2 should have gig 101 as a designated port, gig 102 as a root port, and then 105 and 106 are what? Yes, they're alternate, they're blocking. Traffic's not going to be flowing through them. So let's take a look at that now on DSW2 with the command show spanning tree VLAN 10. And gig 101 is designated forwarding, as we said. Gig 102 is the root port. And there's our 2 block ports right there. So you can see how we were able to identify the spanning tree topology on our own. Just by using the topology, knowing the links and the connections that are involved, and then running through the algorithm ourselves by finding the root bridge based on the priorities, and we were using default priorities. If, therefore, the MAC address broke the tie, and we use show version to find that base Ethernet MAC address that's used with spanning tree protocol. And then we went from there and looked at the root ports and the designated ports, and in the end, ultimately determined the blocking ports and successfully created the spanning tree topology on paper exactly as our Cisco Catalyst switches and our topology sees it. This is a very important skill to have. So practice as much as you can building your own spanning tree topologies and being able to identify the topology without getting the help of the iOS and the show spanning tree commands.